Hello, this is Lab12 Nonparametric Methods in SPSS. This week, we will practice running several the nonparametric method using the LearnThis dataset. We will deal with 5 nonparametric methods. 1. The chi-square goodness of fit test. 2nd, the chi-square test of independence. 3rd, the Wilcoxon sign test. 4th, the Mann-Whitney U-test. And 5th, the Kroll-Skull-Warnes analysis of variance. Briefly speaking, when the dependent variable is nominal, then we need to choose the chi-square goodness of fit test or the chi-square test of independence. Oppositely, when the dependent variable is ordinal, then we need to choose among the others the Wilcoxon sign test, Mann-Whitney U-test, or the Kroll-Skull-Warnes analysis of variance. So, when you read each scenario, please think which variable is our dependent variable and whether it is nominal or ordinal. Let's start. As we usually did, create your 3 files, do file, log file, and Word document. Let's do it. Open SPSS, open data. I saved DTA version, so LearnThis DTA, paste. So our syntax editor, I already did, sorry, block and run it. So I have the data editor and syntax. This is alpha file. This is syntax editor. Let's look at the number 3. There are children attending public school who had been diagnosed with learning disabilities equally likely to be placed in a resource room for part of the day versus in a full-time self-contained classroom. Perform a chi-square goodness of fit test to make the determination. Use the code below and alpha equals 0.0105 for the significant test. Let's follow the process. Analyze nonparametric here, and legacy diagnose here, and chi-square. Change the display variable names here, much clearer, right? The placement into the test variable list, and the expected value box, click the circle next to the values. Type values and type 50 and click add, and type 50 again, 50, and add, then 250, right? And click paste, then open the syntax and run. Then look at our results. This chi-square test results, depending on types of placement, RR and MIS, there is observed number of N, the 66 student and a 39 student. Total was the 1 of 5, but we set to 50-50, so expected N was 50-50 was the 50% versus 50% is the 52.5, 52.5. So when we run the chi-square goodness of fit test, then our test statistic results is here. Our significant value is 0.008, so we can say it is significant. Can you guess what was our null hypothesis of this test statistics test? In here, our null hypothesis was the students equally likely to be placed in two groups. So the mean of the part of the day students and the mean of the full time of students are equals. So, but our result is significant, right? Our result is significant, so we can say they are different. They're significantly different between the part-time group and a full-time group. Next, number 4. Are there gender differences in the type of placement assigned to public school children who have been diagnosed Number 4. Are there gender differences in the type of placement assigned to public school children who have been diagnosed with learning disabilities? So, yeah, we want to see that there is gender differences in the type of placement, right? So, in that case, perform chi-square test of independence. So, analyze descriptive statistics, crosstab, right? Then move gender to row box and change the placement into the column box and statistic, and we want to check the chi-square. So, and click continue and paste and syntax editor, then run. Then we can find the chi-square test by, yeah, this is crosstab results. These are the crosstab results. Then there is no missing values, and these are same with before, right? But it is much more information about gender. So the above one is one way ANOVA, right? One way, but this case is kind of two way. The type of placement multiply gender. So this is our chi-square test results. And when we look at the significant here, the Pearson chi-square, this one is what we want to see. So the significant value is 0.284. It is excuse me. It is it is larger than 0.05. So we retain the null hypothesis that there are not the significant gender differences in type of placement. And number 5, the two elementary school children diagnosed with learning disabilities perform better in math comprehension or in reading comprehension. Because the distributions for math comparison and reading comparison are significantly skewed, so we cannot use any t-test or NOVA test. So perform the Wilcoxon sign test to answer the question. Alpha equals 0.05 and run analyze nonparametric test and 2 legacy diagonals and 2 related sample here, and change the name and move read comp and math comp. And check sign as a test type and click paste. And find the syntax editor and run. And this is our Wilcoxon unsigned rank test. So yeah, when you look at the SPSS output, you need to interpret the results. And here, the math minus reading is negative rank. So math, it is same, this is A, B, C, so it is same with this A, B, C. So A means math minus reading, the negative, so reading is moved to the other hand, so math is less than the reading. The B means the math is larger than reading, and C is both are tied. So when we do these results is for about A, so our the math minus reading was A is negative. So math is less than reading. This our null hypothesis is reject because we have the 0.000 the p-values. So the 0.000 is less than 0.05. So we conclude that the elementary school children diagnosed with learning disabilities perform significantly differently on math comparison than reading comparison. So we can say math, we reject the A hypothesis, so we can say the math comparison are higher than on reading comprehension. And number 6. Is there a statistically significant difference in reading comprehension depending on type of placement? Because the distribution of reading comprehension is significantly skewed, not a normal distribution, and the sample size is not large enough to compensate. So we cannot use the t-test or the NOVA test. So to perform the Mann-Whitney U test to answer the question, and alpha equals 0.05. So number 6, analyze nonparametric test and legacy diagonals and 2 independent sample. Here. Change variable names and move placement into the grouped variable box and define groups as coded 0 and 1 and click continue. and read comp into the test variable list and click paste. And we will do the Mann-Whitney U-test. Then look at the syntax editor and highlight it and run. And these are the Mann-Whitney test results. So our null hypothesis was there is significantly no differences in reading comprehension depending on type of placement. The result, when we look at the significant level, is 0.000, yay! We can reject our null hypothesis. So we can say there is a statistically significant difference in reading comprehension depending on type of placement. Finally, the number 7. Are there statistically significant differences in reading comprehension by grade? It is different with above here. Here is just just two types of placement, right? But the number 7 is, several categories by grades. So in that case, we can use a cross-correlation analysis of variance. Of course, as same the above, the 4th grade reading comprehension scores are significantly skewed, not a normal distribution, and the sample size is not large enough to compensate. Then, in that case, we perform the cross-correlation analysis of variance to answer the question. Let's do it. Analyze nonparametric test, legacy diagnose, k-independent samples. Change the name, move grade into grouping variable box, and define as range minimum 1 to 5. Click continue. To move read comp into test variable list box and paste. And find the syntax editor and highlight and run. And this is our cross-correlation test results. There is 1, 2, 3, 4, 5 grade levels and number of observation and total number of students. And the test statistics, our test statistic results was p-value is 0.026. So this one is less than 0.05, so we reject the null hypothesis in favor of the alternative that the populations from which these samples were drawn do not have identical distributions in terms of reading comprehension by grades. Some of the students asking about the mean, what is meaning of the mean rank. So it is kind of relative. So we can say the low grade students can get more higher mean, but we don't know each of the tests by grades are not same or not, so we don't, each test difficulty could be different, so it's not it is not sure, but anyway, so we cannot say the grade 5 students are dumb more than the grade 1 level. We cannot say it like that. That's all. Number 8, we're done with Lab 12. Yay! If you have any more questions, please send an email or or come to the office hour. Good luck on your and thank you.